Okay, we're going to keep moving on with the appendix. We're going to jump to this third section here, which you've seen a lot of before, but it's also going to be an extension of some things. So polynomials, rational expressions, and hidden within that is everyone's favorite math F word. So first thing, quick little recap, adding, subtracting polynomials. You guys know polynomials are just a collection of numbers and letters and powers. Okay, so you can do a lot of different things with them. Add them, subtract them, divide them, multiply them. When you see these things here, obviously you got one big polynomial here, you got another big polynomial here. Think about what it's asking you to do. So if you get in the habit of double distributing, or if you get in the habit of adding and you see something different, it can often lead to bad results. So we're subtracting them, so keep that in mind. What happens when you subtract through parentheses? All your signs have to change. You're subtracting that huge blob there. So all these signs change. This one obviously stays the same, so we'll copy it again. Now it just becomes basically an addition problem because you've already taken care of the subtraction. We know you have to combine like terms. You can only add things that have the same power to them. So I'm going to go ahead and pause the video here and meet you guys with the answer. Okay, so as you guys can see, how I go about doing this is underlining common terms with 1 line, 2 line, or 3 lines. So first thing I saw was an x to the 4th. It's the only x to the 4th. I put 2 lines under x to the 3rds. The 8 x's actually cancel each other out. I always circle consonants for some reason, just something I've always done. So I copied all that down, combining the like terms, and then I noticed this minus 10x squared didn't have anything over here, so I threw it on the end, and then I just put it together into standard form, so decreasing order of your exponents. Next thing, double distributing. You guys have been doing this for a while, but it's a good little recap here. I'm going to show you how to check and see if your answer is completely correct. Some people may call this FOIL. I don't, because it only works for this first example. When you get to the second example, you don't really have an outer, an inner, and a last anymore. So remember, you're basically just taking each term in each parenthesis and multiplying by everything in the other parentheses. You know, so this one, 6x squared plus 14x minus 15x minus 35. Okay, go ahead, combine your like terms again. The only problem with these is you got to make sure you get your signs correct, so as far as the positive negatives go. So you guys have been doing that one for a while. Now when you get to the second piece here, FOIL doesn't work because you're bringing this x over into 3 different things. So we just say double distributing. We don't say FOIL for anything. So we do this first time through, making sure x's times x's, powers bump up accordingly, all that. Now we come back and we take care of the -2.
You're not recording now, are you?
Make sure the -2 times the -5 gets you to positive 10. Go ahead, collect all your like terms. Now, if you guys want to check and make sure if these things are correct, one thing you can do is use your calculator. So double distributing is just basically the opposite of factoring. So if you think if you double distribute this correct, if you really want to make sure, you can go to your calculator here, go to the y equals, plug in the factored form, which is where we started the double distributing. And in the next line, plug in the standard form. Now, if these are the same, if you go to your table, you should get the same numbers. So basically, like, if you say, you know, let x equal 4, and you plug a 4 in everywhere you see an x and you do all the operation. You plug a 4 in everywhere you see an x here and you do all your operations, you get the exact same number. You plug in a 4, it spits out a 46 in both of them, so you know you did that correctly. So up here I say, check in your calculator if you want, and you can know you did that correctly. That also works for factoring, and we'll go through that as well. Okay, last example here. If you see something like this, x minus 3 cubed. So you guys are going to write this like this. Now it's important when you do these types of problems that you only focus on kind of 2 parenthesis sets at a time. You don't want to be bringing them between all 3 of them. So we're just going to kind of ignore this one right now, and we're going to focus on those first 2. So do a simple double distribution like we did up top. Make sure you get a plus 9 here. Collect your like terms. Now you've done x minus 3 quantity squared. Bring down this last one, and this problem just becomes the exact same thing as the one we did before. But now you have the term with 3 things first and the binomial second. So I'm going to pause it here. I'll meet you guys with the answer after the break. Okay, so I double distributed all that. I color coded it, if that helps you. You're welcome to grab colored pencils, markers in class, if that helps you keep everything in order. It's all color coded down here as well. Collected all the like terms, and we get to our final answer. In Y1, I plugged in the factored problem. In Y2, I plugged in the standard form thing. If you go to the table, the numbers match up. When you plug in a 4, you get a 1. When you plug in, as long as the tables are the same here, you know you did it correctly. Okay, next piece, everybody's favorite math F word, and that, of course, is factoring. So this section has a ton of different types of factoring in it. We're going to break it down by types over the next couple days. Eventually, when I assess you guys on this stuff, you're just going to have to know how to factor each type of problem. These are difference of squares or force. What's handy is your chart of all the perfect squares. They're very special numbers. You should know them. When you see them, kind of keep that stuff in mind. 1, 4, 9, 16, 25, 36, etc. Okay, factoring is just the opposite of double distributing. So what would you have to double distribute to get an x squared minus 100? You guys have been seeing these for a few years now too. X minus 10 and an x plus 10. Okay, the middle terms have to cancel. So when you do this and this, the 10x and the minus 10x cancel each other out, and you're going to get x squared minus 100. Again, you can check both those in the calculator. And I encourage you guys to do that so you can know instantly if your factoring was correct. Next one, 9x squared minus 16. They're both perfect squares. There's no b term in the middle as far as a term with just an x in it. So I'm going to try 3x minus 4. I'm going to try 3x plus 4. Okay, middle terms will cancel as long as whatever in the parentheses is the same and you have opposite signs. And for this next one here, x to the 4th minus 16, it's the same idea. There's nothing in the middle as far as an x or an x squared term. So why don't we try this? X squared minus 4 and an x squared plus 4. If you double distribute that, x squared times x squared gets you x to the 4th. Middle terms will cancel. You get the minus 16. Now the trick with this one is you're not completely done. You got to break up this x to the 4th here, or x squared minus 4. That itself is its own perfect square. X minus 2 and an x plus 2. Now, x squared plus 4, there's nothing you can do with it, and that kind of comes over and takes away from this example here. There's no sum of squares. Okay, there's nothing you can do. So like if you think x squared minus 16 is able to factor, you might try x plus 4, x plus 4. But what happens is you get that middle term of 4x and 4x, which gives you 8x, but there's no 8x in the middle there, so there's no sum of squares. Okay, so the book refers to those things as prime. So we would just say, you know, it's not factorable, it's prime, or you just kind of leave it alone type thing. Last one here with these difference of squares, x to the 6 minus 25. 6 isn't a square, but 25 is. So why don't we try this? X cubed minus 5, x cubed plus 5. Now, if you do an x to the third times an x to the third from yesterday, you guys will remember when you multiply exponents, you add their powers. So that's actually going to work. Middle terms will cancel. Negative 5 times 5 gets you negative 25, and you're good to go. Now, you can't break this down any further because what are you going to multiply by as far as perfect squares go to get to a 3? You need a 2 and a 1, and then 5's not a perfect square either. Next, sticking with factoring, we're going to look at sum and difference of cubes. So I threw up all your perfect cubes, 1, 8, 27, 64, 125. Notice how quickly those blow up compared to the perfect squares. So when you get to 8, you're already at 512. You know, 8 squared is 64, so they blow up much, much quicker. So when you see one of these numbers, keep in mind that you may be doing sum or difference of cubes. These ones are different, as you can see over here with your two formulas. Maybe you guys have worked a little bit with these before. You are able to do a sum of cubes. Okay. Let's start here with this one, x cubed minus 8. It may be helpful to rewrite it this way. X cubed minus 2 cubed. Now it matches up perfectly with this formula right here. So it's always the cube roots of them, a minus b according to the formula. Now it's always a squared. If you follow the formula, it's an addition sign plus 2x plus 4. So if you sat there and you double distributed all of this stuff, everything in the middle would cancel out, the x squareds and the x's. You're only really left with your first term and kind of the last thing here. All the stuff in the middle goes away. Okay, and that's kind of following the formula. If you'll notice, if it's a difference of cubes, the first term has a subtraction, everything else is positive. If it's a sum of cubes, first term has a positive, then a minus, and the last term is always positive. So you know these are always positive, these will change, and these will change, but it's easy to remember. If it's a subtraction, it's subtraction. If it's addition, the next one changes. Okay, so we'll get lots of practice with these sum and difference of cubes. Now, if we take the same problem, we make it a sum of cubes. Formula's just going to change as far as positive and negatives go. Now, again, you can throw this in your calculator into y1, this into your calculator into y2, and you're going to get the exact same things if you go to your table. A little challenge one here with sum and difference of cubes is this last one, 8x cubed minus 125. So we know 125 is 5 cubed. We see it on our list up here. 8 is also on the list, and I'm going to write it like this. Quantity 2x cubed. Okay, 2 times 2 times 2 gets us to 8. Now, if you want to use the formula, this whole thing is going to be your A. This whole thing is going to be your B as far as the 5 goes. So it's a difference of cubes. So we're going to be using this one right here. So we need to do an A minus B. 2x is my A. B is a 5. Now we need to do A squared. But what is 2x quantity squared? It's 4x squared. Just think about what has to happen when you do that first double distributing. You need to get to 8x cubed. 2 times 4 is going to get you there. 2 times 2 is not. Now we know it's a plus sign. Now it's A times B. So 2x times 5 is 10x. Okay. The last one is we need a b squared, and we know it's positive. If b is 5, squared is 25. Now, you get two choices to see if this is correct. You could sit here and you can double distribute all this stuff, or you can throw it in the calculator. And I'm going to pause it real quick and just make sure we did that right. Okay, again, threw one factored form in there, threw one double distributed form in there, and you can see when you go to the table, you get the exact same thing, so we know we did that right. Those are some special cases with factoring. Okay, now we're going to get into the trinomials. You guys have been doing factoring for a long time, since Algebra 1. You did it in Algebra 2. Some of these are going to be a little bit more difficult. If you have a method that works for you now, go ahead and do it. I'm going to show you guys kind of a little different way here. These work well if the a value is a 1. And if you guys are able to get these factored, you can go ahead and skip through the video till the next piece. So this is kind of something we've been doing in the department new the last couple of years, this idea of factoring by grouping. So again, this only works well if the a value is a 1. If it's not a 1, we'll show you something different in just a minute. So I need to multiply to 15, and I need to add to 8. Okay, so if I write it like this, I can split that 8x up into whatever I really want. But if I split it up into two things that give me something I'm able to factor by grouping with, then it may help me out. So now I'm just going to look at these two things. The GCF between them is an x. I'm left with an x plus 3. Come over here, look at this piece. The GCF between them is a 5. You're left with an x plus 3. So then factoring by grouping, as long as you have the same things here, you can take these two things with their signs and put them together. So this factors x plus 5, x plus 3. Okay, now you could have switched this order here because 3 is also a factor of 15 and gotten the same thing to work as well. Okay, let's try it over here with something a little bit different. So I need to multiply to 8 and add to -2 somehow. So what if I split this up into this? Minus 4x plus 2x and a minus 8. If you add those middle terms together, you should get here. Now we look for GCFs with this first piece. We look for GCFs with the second piece. And we got it to work. Now, because you guys have seen these standard examples before, I'm going to go ahead and pause it, and I'll meet you guys with the factored answer. All right, so the third one here, x minus 4, x plus 6. Like I said, I'm just showing you guys a new method. I don't actually use this one. I just kind of do a guess and check. It's up to you. You guys have seen these for a while. Just giving you some more methods here. This last one, though, is important. The only difference between it and the second one we did, this one was a minus, this one was a plus. If you try this method here, so you can break it, you know, plus 4x minus 2x. Actually, that's going to have to be backwards. This would be the minus, this would be the plus. So then this would be minus, and then this would be plus. But you can see you don't get the same thing in the parentheses. You got a minus 4 and a plus 4, so it's not factorable. Okay, if they get a little bit tougher, so the a value is bigger than 1, again, if you guys can guess and check with these and get them factored, use your calculator, that's great. Okay, we're going to work on these and a couple other methods. You can still use this grouping method, but when the a is bigger than 1, there's another little trick that can kind of help you out. So we're basically combining this x method into grouping. You don't have to use this. I just want you to get these things correct, obviously. So the trick with this x method is you put a times c up top, so we know this is our A value, this is our B, this is our C. So 4 times 15 is 60. Down below, we put negative 16. Okay? On the sides, the two numbers must multiply to the A times C and add to the B. So basically, we got to multiply to 60 and add to negative 16. So off on the side, I just start listing things that are going to get me to 60. 4 and 15, 5 and 12, 10 and 6. Okay, 10 and 6 will get me to 16. So I'm going to throw a 10 in here. I'm going to throw a 6 in here. If I make them both negative, negative 10, negative 6 multiplies to positive 60. They add to negative 16. Now, these numbers that you just came up with will give you your grouping piece. So we want to do minus 10x, minus 6x, and then the plus 15. Now, the 4 and the 10 will work, and a 6 and a 15 will have something in common there as well. You could also switch these if you wanted to, because 10 goes into 15, maybe a little bit better than 6 or whatever, but we still should get the same thing. So GCF out of here, 2x, so you're left with 2x minus 5. Pull the negative 3 out of here, because that's what these have in common. You're left with x. Make sure this changes signs. Whoops, you're left with 2x minus 5. Now, these are the same, so we're good. 2x minus 3, 2x minus 5. You can check that in your calculator if you want, or double distribute it back out, but we should be good with that. Okay, here's another example of how to use this x method into the grouping. 8x squared minus 14x minus 15. So I'm going to do A times C up top. So 8 times 15 is negative 120. The B value is negative 14. So just start listing stuff. What multiplies? Well, I guess we don't have to worry about signs right here. What multiplies to 120? 2 and 60, 3 and 40, 4 and 30, 5 goes in there 24 times. 6 is going to go in there 20 times. 6 and 20 can get you to 14. We need negative 14, so we're going to go negative 20. These two numbers multiply up. These two numbers add down to negative 14. There's our grouping. So 8x squared minus 20x minus 6x minus 15. Let's see what happens. GCF between these. Pull out a negative 3 here. Oh, we messed that up because that needs to be a positive 6x right there, so that's going to help us because we had a positive 6 over here. We just wrote that wrong. Let's pull a positive 3. 2x minus 5. These match up. 4x plus 3. 2x minus 5. Check it in your calculator or check double distributing, and it should be good. Okay, 2 more examples here. First is, what if you have a GCF with a number? Second one's going to be, what if you have a GCF with your variable? Okay, process is still the same. Again, you guys have seen these before, but in case we need a little review here, we'll go through it. So 3, 12, 36, your X method actually won't work unless you always factor out your GCF. Okay, and it's also going to make the problem smaller, or the number smaller, which is easier for us to do as well. Okay, so I'm going to pull the 3 out, see what I have. Now keep the 3. Now your a value is a 1 here, so I'm just going to kind of guess and check this one. What multiplies to 12 adds to -4, and you're going to leave it like that. 6 and a 2. Okay? Last one here, what if you have a GCF with your variable? Now this isn't a quadratic because you have that to the third power there. So everything we've been doing has been quadratics. Okay? If you have that third power there, you're probably going to notice all the terms have x's with them. You also have 4, 14, and 8. So there's a GCF with the variable, but also the number as well. So I'm going to pull a 2 out, and I'm also going to pull an x out. Okay, again, you can double distribute this 2x through. Make sure you factored correctly. Now, that just gets us to this piece here. Nothing you can do with the 2x, so we're going to keep it. So we need to look at this. So if we do x method here, a times c, -8, and a 7. What multiplies to 8? 8 and 1, 4 and a 2. How are you going to get to 7? 8 and 1, we'll do 8 and a -1. Multiplies up and it adds down. These numbers on the side will give us our grouping. So we'll copy 2x squared. We got 8x, we got -1x, and then a -4. So let's factor these with the GCF. X plus 4. Now, over here, the only thing in common is a -1. So if you pull a -1 out, both the signs of those are going to change. Now, there's your factoring by grouping. So 2x minus 1, your x plus 4. Don't forget about this first GCF that we factored out. Go to your calculator, throw this in y1, throw this in y2, make sure that they both agree. Now that lesson was a little bit longer than some we like to do. Some of you guys may have watched the whole thing, some of you guys may have just paused it and cranked through some of the factoring because you remember that stuff. We do try and keep these things about 20 minutes. I'm going to do 2 more additional practice ones here, just in case you guys want to see that. If you're good with these, we'll see you in class tomorrow, ready to get to work. If you want a little bit more practice, we'll see you after the pause. Hey, here's 2 more kind of tougher trinomial ones that I just picked. You guys can guess and check if you want. You can use that X method into the grouping. You can pause it, or you can kind of watch me go through this thing here. So if I take this first one, a times, there's no GCF with the numbers or with the variables, so a times c, throw the b down here, 14 and 1, 2 and 7, negative times a negative, multiply to a positive, add down there. I have my groupings now, so 14x squared minus 2x minus 7x, that's how we're splitting up the 9, plus 1, GCF these. The only thing that we have here in common is I'm going to always pull out a -1 here. So this is going to go to -7x minus 1. These match up. So 2x minus 1, 7x minus 1, double distribute or check in your calculator. Okay, next one, no GCF with the numbers, no GCF with variables. So let's do X method into grouping. -5 times 12 is -60. This is 28. 2 and 30. So if I did a 30 and a -2, they'll multiply up, they'll add down. There's my groupings. So 12x squared plus 30x minus 2x minus 5. GCF these, they got a 6x in common. If this is a negative, you're always going to pull that out. This is going to change. Now remember, there is a -1 right here, even though I didn't write it that time. And there you go. Check in your calculator or by double distributing. We'll see you guys tomorrow in class, and we'll do a lot of practice with this stuff.